Honey. Honey is a natural product made by the honey bee. It has viscosity due to the slipping of the fluid layer about each other. For extracting the honey, it is essential to know its viscosity. The high viscosity of it arises due to thickness or vice versa. Extracting the honey from the honeycomb, filtering, and storing it sometimes becomes difficult due to its high viscosity, thickness, and stickiness. It usually depends upon the amount of water present. With increased water, honey becomes less viscous. Temperature too has an impact on its viscosity. Heat usually makes it less viscous. Blood. Blood is another one of the common viscosity examples. The flow of blood in our body is a laminar flow, that is the layer of blood that slides on one another. The central layer moves faster than the outer layer of blood near the blood vessel. The blood needs to be viscous, but the high viscosity does not allow blood motion. The high viscosity can lead to turbulence that further damages blood vessels. A level of viscosity should be maintained in the blood for proper motion and blood pressure. When the blood is too light, it causes severe health issues that should be avoided. Bitumen. Bitumen, also termed asphalt, is a thick gooey material derived by the distillation of crude oil as a byproduct. It is used in the construction of roads. The upper layers of a road are where all the pressure and load acts. It also protects the road structure. Hence the bitumen is commonly chosen on the factor of its viscosity. The viscosity bitumen gets soft at increased temperatures and hardens at mild temperatures. This unique property determines many of the factors of the roads. Cooking oil. Cooking oil is generally fat found in a liquid state. It is also a viscous substance. The layers of oil resist each other's motion. That is why it is seen that it does not flow as much when the oil is thick. However, the oil of thin consistency flows easily. The oil can easily be differentiated by its viscosity. It should be taken into consideration while choosing a cooking oil, as temperature influences the viscosity. So while cooking, the change in viscosity leads to a change in taste and texture of food. Engine oil. Engines are manufactured with the help of many parts that rub against each other to build friction. This leads to wear and tear of the parts, thus destroying the efficiency of the engine. Therefore, engine oil is used. It forms a layer over the moving engine parts to protect them against friction. The viscosity of engine oil deduces the pouring ability if oil pours at a specific temperature. Lower viscosity means thinner oil, and higher viscosity leads to thicker engine oil. During cold weather, the lower viscosity oil helps in the easy movement of engine parts. At the same time, high viscous oil is better at high temperatures and loads. Lubricant. A lubricant is a fluid that helps in reducing the friction between any two striding parts. It is one of the basic viscosity examples. The viscosity of lubricants is one of its most essential properties. It determines friction losses, load potential, and film thickness. It is a physical measure of a fluid's proficiency to ultimately deliver film lubrication under certain conditions. If the viscosity of the lubricant is too high, the machine has to work harder, which leads to more consumption of heat and energy. At the same time, the low viscous lubricant provides enough protection against friction. Generally, the optimum viscosity of the lubricant is determined as per the operating conditions of the machines. Paint. Choosing the right paint for your place is a challenging task. Out of many factors that we look after, viscosity is one of the important ones. It is a measure of the resistance offered while spreading the paint. Therefore, viscosity helps us calculate how much paint is required to cover a particular area. Apart from that, it also specifies the probable calibration brushes. The thick paint covers a larger area than less viscous paint. That is why before painting, the viscosity of the paint is adjusted. For airbrushing, thicker paints needs more air pressure to spread evenly on the walls. And most importantly, we know that temperature affects viscosity. Hence the temperature of both paint and the wall determines how much it will spread. Super glue. Super glues is an adherent that leads to coalitions on reacting with air's moisture. The super glue is graded on its level of viscosity. It is available in both liquid and gel form. For cracks or fractures, liquid glue is used as it penetrates the holes and dries faster than gels. The higher viscous glue leads to less dripping and hence more control over the glue. The low viscosity glues are suitable for flat or leveled surfaces. Most of the applications make use of medium viscosity type as it can be controlled and provides strong adhesive. Ink. The printing ink comprises components like pigment, additives, and solvents. The ink is a viscous substance. The viscosity specifies the thickness and longevity of the final product. In this case, viscosity refers to the degree to which ink will show resistance to the flow. It depends on the printing process and the nature of the material to which it will adhere. The viscosity varies as per the stresses offered and helps in the transfer of ink from the analogs to the plate and there to the printing substrate. The press output speed and the nature of the print are associated with the ink viscosity. Hair gel. Hair gel is one of the viscosity examples. The layers of hair gel slide over each other, which creates resistance. The high viscous hair gel leads to a thicker consistency and less flow. In comparison, the low viscosity means thinner and flowy gel. The viscosity of the gel should be high enough so that it can shape your hair and fix them as per your desire. Sanitizers. Viscosity is a significant property to evaluate when preparing hand sanitizers. Hand sanitizers come in the form of gels and act as a disinfectant by killing off the germs before evaporating away. The low viscous gels are easy to handle, but they dribble away, which leads to waste of product. Too high viscosity slows down the evaporation process, leaving the hands slimy. Hence, it is vital to sustaining an acceptable degree of viscosity of the sanitizers. Liquid hand wash. Liquid hand wash is an essential hygiene item. It is a group of entities having identical properties that are all soluble in water, soapy, and can wash oils and dirt from hand. It is also one of the viscosity examples. The viscosity of hand wash is one of the important factors. It varies according to the temperature and evaporation. The optimum viscosity of hand wash should be enough to let it flow easily. Too high viscosity leads to lower dosing volume per stroke. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. You can check our other website as well. We have features like YouTube trends, Twitter trends, scientific calculator, and many more other tools. If you like our video, please like, comment, and share. If you have any questions, please comment and we will resolve your query.